Assalamu alaikum students. Today we will do exercise of chapter number 4 gases, and this is question number 12 of your textbook exercise of chapter number 4. And first question is, sodium is softer than copper. Sodium is softer than copper, but both are very good electrical conductors. Give reason. Now we will explain why sodium is soft and both are good electrical conductors. The forces in metallic solids depend upon the number of valence electrons. Students, reminded, the forces in metallic solids. In solids, when we see structure of metallic solids, forces present in metallic solids depend upon the number of valence electrons. Greater the number of valence electrons, stronger the forces. नंबर ऑफ इलेक्ट्रॉन्स, वैलेंस इलेक्ट्रॉन्स एटम्स के जितने ज़्यादा होंगे उनके एटम्स के दरमियान फोर्सेस उतनी ज़्यादा स्ट्रॉन्ग होंगी. सोडियम हैज़ लेसर नंबर ऑफ इलेक्ट्रॉन्स इन इट्स वैलेंस शेल. सोडियम is member of group first alkali metals, and sodium has only one electron in its valence shell. It has lesser number of electrons in valence shell, therefore it has weak forces. And as compared to copper has more number of valence electrons, therefore it has stronger forces, and thus due to weaker forces sodium is softer than copper and copper is stronger than sodium. However, both metals have free electrons. It is the property of every metal that they have free electrons in their metallic cluster, hence both are good conductors of electricity. However, due to more free electrons in copper, it is a better conductor than sodium metal. Okay students, this is the answer of first part of question number 12. Now we will move towards the second part. Second question is, diamond is hard and electrical insulator. Diamond is hard and electrical insulator. Explain it. We can explain it as, in diamond, each carbon is sp3 hybridized. Each carbon is linked to 4 other carbon atoms through covalent bonds, and all the 4 valencies of carbon atom fully satisfied. Due to strong bonding in diamond, it is hard. However, in diamond crystal free electrons are not present, therefore it cannot conduct electricity, hence it is an electrical insulator. When free electrons are absent in any substance, that it will be insulator, because free electrons are means of conducting electricity. So in diamond, free electrons are absent, so it is insulator. It cannot conduct electricity due to the absence of free electrons. It is electrical insulator. Okay, now we will move towards question number 3. Sodium chloride and cesium chloride have different structures. Why? Explain it. Sodium chloride and cesium chloride have different structure. Now we will explain it. Sodium chloride and cesium chloride have different structure. It is because sodium ion is smaller than cesium ion. Here size, it depends on size of atoms, atomic ratios. It is because sodium ion is smaller than cesium ion. The sodium ion is surrounded by only 6 chloride ions, and as the size of sodium is smaller, so it is surrounded by only 6 chloride ions in NaCl crystal, and its coordination number is 6. Coordination 6 means only 6 atoms can be attached directly with the central metal atom, while due to larger size of cesium ion, it is surrounded by 8 chloride ions. Thus its coordination number is 8. Moreover, due to different sizes of sodium and cesium ion, both NaCl and CSCl have different radius ratio. Radius ratio is equal to, please students note it, radius ratio we can find by the formula is equal to radius of cation divided by radius of anion. It is used to express the relative sizes of different ions. Example, the radius ratio of NaCl is 0.53 and radius ratio of cesium chloride is 0.93. From radius ratio we can also, this radius ratio shows that NaCl Na sodium ion has smaller size. Now we will move towards the next short question. Iodine. Question number, we will move towards the question number 4. Question number 4 is iodine dissolves readily in tetrachloromethane. Why? First of all, students, you must have to note that the process of dissolution obeys the rule like dissolve like. If dissolving substance solute is polar, then it will dissolve only in polar solvent. If it is non-polar, it will dissolve only in non-polar solvent. Here case is iodine. Iodine is non-polar. Iodine is non-polar, so it will dissolve in non-polar solvent tetrachloromethane. Okay, next number 5. The vapor pressure of solids is far less than that of liquids. In solids, intermolecular forces are much stronger than liquids. Thus, it is very difficult to vaporize solids. Hence, solids have far less vapor pressure than liquids. Here, less vapor pressure reason is strong intermolecular forces present in solids than liquids. Okay, now we will move towards the question number 6. Amorphous solids like glass is also called supercooled liquid. Why we call it supercooled liquid? Supercooled liquid, true solids have ordered arrangement of particles, while liquids have somewhat random structure. Amorphous solids have definite shape and volume, however these have random arrangement of particles, thus their molecular structure is more like liquids. While molecular structure of amorphous solid resemble to that of liquid, therefore these are called supercooled liquid. And for example, glass, rubber, etc. These are the examples of amorphous solids. Next question is question number 7. Cleavage of crystals is itself anisotropic behavior. Why? First of all, you must know that what is anisotropy. Anisotropy is that property which depends on the direction, and each crystal has definite arrangement of particles. Therefore, a crystal can be broken easily in a particular plane only and not in any other plane. Thus, cleavage depends upon the direction of plane. The properties which depend upon the direction are called anisotropic properties. Hence, cleavage is an anisotropic behavior. Okay, we will move towards next 8th question. The crystals showing isomorphism mostly have the same atomic ratios. Crystals showing the isomorphism mostly have the same atomic ratio. Why? We will explain it as a crystalline form does not depend upon the chemical nature of atoms. Crystalline form does not depend upon chemical nature of atoms. It only depends upon number of atoms, size of atoms, and way of combination of atoms. Hence, substances with the same number of atoms, that is, same atomic ratio, generally have same crystal structure, and hence they are isomorphous. For example, NaNO3, KNO3. Look, students, here. NaNO3, KNO3. Here sodium, यहाँ sodium, nitrogen and oxygen ratio in both 1:1:3, so they have same crystal structure and same ratio, atomic ratio. Okay, now question number 9. The transition temperature is given. Yes, the transition temperature is given by elements having allotropic forms and compounds showing polymorphism. Transition temperature is given by the elements having the allotropic forms and compounds showing polymorphism. First of all, the definition of transition temperature must be known. The temperature at which transition of one crystalline form to another crystalline form takes place is called transition temperature. Different allotropic forms of elements and polymorphous forms of compound can be converted into each other by controlling temperature. This concept of transition temperature cannot be used for substances which have only one form. Hence, transition temperature is only given by elements showing allotropic and by compounds showing polymorphism, since they exist in more than one form. Okay, students. Okay, remaining questions will be conducted in the next lecture. Okay, I hope you have understand these all these points, and these are very important short questions from examination point of view. So please try to solve these and to give answer of all these short questions, and fully practice it. Okay, thank you.